Now let's look at the equality of complex numbers. Two complex numbers are equal if their real parts are equal and their imaginary parts are equal. Now, an application of a question that might be used to see if you get this concept is an example such as this one. Find x and y such that 2x plus the square root of negative 9 is equal to 12 minus yi. I want these two complex numbers to be equal to each other. Well, in order for them to be equal, their real parts, the part of the number that does not have the factor of I, they have to be equal to each other. But it also has to be true that their imaginary parts, the coefficients in front of the factor of I, have to be equal to each other. Now, in order to see those components of this particular example, we need to rewrite it in simplified form so that we can really see where our comparisons are. On the left-hand side of the equal sign, we have the 2x, which can't simplify any further, and then plus the simplification of the square root of negative 9. Well, there's a negative under an even index, under a square root. So when we're working with the complex numbers and we have a negative under the square root, I think of the simplification without the negative sign on there. So the square root of 9 is 3, but because there's a negative under the square root, we would go 3i, because the square root of negative 1 is I. So we have 2x plus 3i is equal to, and then on the right-hand side of the equation, we have 12 minus yi. And there's no more simplifications I can do on that side. So I'll just write 12 minus yi. But now I can compare the parts that have to be equal. The term, identifying the terms on each side, I have 2x is a term, plus 3i is a term, and then on the right-hand side, 12 is a term, and negative yi is a term. Now the terms without the factors of I are the real parts, and it says they have to be equal. So on the left-hand side of the equal sign, the term that doesn't have a factor of I is the 2x, and that has to be equal to, on the right-hand side, the term that does not have the factor of I is the 12. So 2x has to equal 12, and we can solve that by dividing both sides by 2, and that gives us x is equal to 6. But it also has to be true that the coefficients in front of the I on both sides of the equal signs have to be true. So my coefficient in front of my I on my left side is 3. And on the right side of the equation, the coefficient in front of the I is negative y. So it also has to be true that 3 is equal to the opposite of y. Solving this equation, we'll divide both sides by negative 1, and we'll get negative 3 is equal to y, or we'll write y is equal to negative 3. So those are our values for x and y, so that the original complex numbers will be equal to each other.